On a scale of 1 to 5, I'd say this question is definitely a level 5. It's a tough question. A lot of moving pieces, a lot of background information you need to know. One of the things definitely you have to be comfortable with is your exponent rules. And then after that, you have to know the common quadratics. So let's start with understanding what the quadratic rules are. Or no, sorry, not the quadratic rules, the exponent rules that you need to know over here. Now, if I have, let's say, x to the negative 2 over 1. One thing that I need to know is that this is the same exact thing as 1 times x squared. So the denominator, if there's a negative exponent, you can bring it up and the exponent becomes positive. So working with the original information they give me. Sorry, let me get this out of the way because I'm going to need all the room I can get for this problem, I think. So start here. See how this is a negative exponent? Let's bring that up there. So that'll become x to the a times x to the b equals x to the fourth. Now, let's stick with this for a little while. Let's see how else we can rewrite this. Now, when you're multiplying exponents, like I am over here, so I'm multiplying x to the a times x to the b, and if I have the same base, I can add my exponents. So really this expression right there is the same thing as x to the a plus b equals x to the fourth. So this is really as far down as I can take this, and also from this I should be able to tell that a plus b has to equal 4, right? And I'm just putting all this information down, trying to gather as much as I can from this one little piece of information they give me. And the reason I know a plus b is 4 is, see how it's saying x to the a plus b over here, and this is x to the fourth, and they're equal to each other. So that means that this number over here must be 4, because if this was 4, then x to the fourth and x to the fourth would equal each other. So that's why I know that the value of a plus b must be 4. So I've really gathered as much as I could from this side. Now let's go over here. Same exact thing here. See how I have a negative exponent here and here? Let's bring it to the top. So the exponents become positive. So this will just be x to the 2ab. And remember, there's a 1 there. That 1 is still there. I'm just not going to write it down because that 1's not going to affect anything. And this will be x to the 8th. Now over here, same exact thing as here, right? I know that the value of 2ab must be 8. Just because the x to the 8th equals 2 to the ab. So 2 to the ab must be 8. And then I can also divide both sides by 2. And then I know that the value of a times b is 4. So crucial pieces of information that I have here, a plus b equals 4 and a times b equals 4. Now, a couple of things to keep in mind here is, one thing I can do is guess and check some numbers, right? I know that the value of, so let's rewrite this. I know that a plus b has to be 4. And I know that a times b has to be 4. So try guessing and checking some numbers. What works here for a and b, and what's going to work for here for a and b? And I think one number that comes to mind right away is 2 and 2. Because isn't 2 times 2 4 and 2 plus 2 4? So I can say that a is 2 and b is 2 because those work for both of these values. Now the final question is saying what's a squared plus b squared equal? So that's just going to be 2 squared plus 2 squared, and that'll equal 2 squared is 4, 2 squared is 4, so that'll equal 8. So I can kind of hack the problem at this point right there, come up with numbers for a and b that work for both scenarios, and figure out my final question. The answer is 8. But now let's say if these numbers were a little bit tougher, where a plus b was 4.5 and a times b was 4 equals 4.25, then it'd be tougher to guess and check some numbers. So let's also figure out the proper way of doing this. And sorry, I have to bring this up here. And I just have to get this out of the way. So I'm going to erase all this stuff right here. Alright, this is going to... So let's make this bigger. Let's get that. And there you go. So I'm going to erase this and leave everything else. Let's get my pen back. Okay, so the common quadratics are this. A plus b times a plus b equals a squared plus 2ab plus b squared. That's one thing that I want to know, keep in mind. And a minus b times a plus b equals a squared minus b squared. That's another one that you want to keep in mind. Then the last one is a plus, which one am I left with? Oh, a minus b times a minus b. oops, I still have the big one. A minus b times a minus b equals a squared minus 2ab plus b squared. So again, I told you it's going to get a little bit messy. See these common quadratics? The SAT likes testing on these once in a while. So keep all of these, write them down, this one, and this one, and look out for when you can use these, and I'll show you how you can use these common quadratics, one of these three, for this particular problem. So copy the second two down, pause it if you need to. I'm going to erase it now though. So the one that I'm going to be using over here is the first one. See how I know that 2ab over here was 8, and I know that a plus b is 4. So I know that this value right there is 4 and that value right there is 4. So that's 4 times 4 equals a squared, plus I know the value of 2ab is 8 plus b squared. Now 4 times 4 is 16, which equals a squared plus 8 plus b squared. And remember, my final question is asking me a squared plus b squared. So let's just get rid of this 8 by subtracting 8 here and here. And I'm going to be left with a squared plus b squared equals 8. And that's what the question's asking. So these common quadratics, if this rings a bell, something like this starts popping up on the SAT when you're taking it, think of the common quadratics that I wrote down. Think about how you can substitute the values that you found out for those and come up with a final answer. On a scale of 1 to 5, definitely a level 5 problem. Might see it, might not see it, but definitely on the tougher side.